All right, so in part two of the extreme values here, we're going to be looking at absolute extreme values, and these are often just simply referred to on the AP exam as the maximum and minimum value of a function. They are not going to take into account your local maximums or minimums. We are looking for the highest part or the lowest part of your function. It could be at a local maximum or a local minimum, but it's going to be referred to as your absolutes. And so there's one other thing that we're going to have to use on this, and that is called your candidates test. The candidates test is always going to have to be used whenever you are looking for absolute maximums and minimums for a function. So what the candidates test does is we are going to find the maximum and or minimum values at the critical points, but we also have to take into account what the y values are at the endpoints of the function. Absolute maximums and minimums can occur either at critical points or at endpoints of a function. So what we will be doing is making a table that will include the endpoints and the critical points, and those will be considered your candidates for where the maximum or minimum will occur. All right, so let's just take a value or a problem here and see how this plays out. This says find the maximum and minimum values of the function x squared minus 8x plus 2 on the interval from 2 to 5. All right, so what we need to do then is first find the derivative. So f prime is equal to 2x minus 8. To find the critical points, we set the derivative equal to 0 and solve for x. So adding 8 and then dividing by 2 is going to give us x is equal to 4. All right, so if you think about a sign chart on this, numbers that are larger than 4, when you substitute them back into this derivative, numbers larger than 4 will cause this to be a positive value. And numbers smaller than 4 will cause this to be a negative value. So if our function is decreasing to the left of 4 and increasing to the right of 4, that means that you're going to have a local minimum at x equals 4. Now that is a local minimum. We do not know for sure if that is the absolute minimum. And we also want to find the absolute maximum for this function over the closed interval from 2 to 5. Now that means 2 and 5, since we have brackets, these are considered the endpoints of this function. And so here's how your candidates test is going to work. You're going to build a table and in this table you're going to have x values and you're going to have f of x values. Now the x values that go into this table are going to be the candidates for where you can have a maximum or a minimum. So the candidates are going to be your critical points, which in this case would be 4, and your endpoints, which in this are 2 and 5. So we have 3 candidates for the maximums and minimums of this function. So to find what the maximum minimum values here are, we need to evaluate each of these. So f of 4, that would equal 4 squared minus 8 times 4 plus 2. So that's 16 minus 32 plus 2, which is negative 16 plus 2, that's negative 14. All right, so we're going to have a negative 14 here. All right, so now we evaluate f of 2. That will be 2 squared minus 8 times 2 plus 2. So that's 4 minus 16 plus 2, which is negative 10. And then we evaluate f of 5. So f of 5 is equal to 5 squared minus 4 times 5 plus 2. That's going to give us 25 minus 20 plus 2. So that's 5 plus 2 is 7. All right, so 7 is the largest value in this table, which means 7 is the absolute max. Negative 14 is the smallest value in this table, which means negative 14 is the absolute minimum. Now, as I referred to earlier, on the AP exam, they typically do not call this absolute max or absolute min. They just say what's the maximum and minimum values. Okay? All right, so the next thing we want to talk about here is going to be the mean value theorem. The mean value theorem says if a function is continuous at every point on a closed interval and differentiable at every point of its interior. All right, so it has to be a smooth curve where it is differentiable. Then there is at least one point C at which f prime of C equals f of B minus f of A over B minus A. Now, hopefully you recognize f of B minus f of A over B minus A. That's just simply a slope formula. F of B is a y value, f of A is a y value. So you're subtracting 2 y values over subtracting 2 x values. So that's a delta y over delta x. F prime is a derivative. So what we are saying is there is a place somewhere between A and B, a point C, such that the instantaneous rate of change at C equals the average rate of change over the interval from A to B. All right, so let's look at this graph down here. We have two values. We have A and B. And if you follow A up to the function, the y value is represented as f of A. And for the x value of B, followed up to the function, the y value is f of B. Now, we have 2 points on this graph now. So we have this point and we have this point. Those represent the interval that we're looking at, so from A to B. Now, if we consider the slope of this secant line that goes between these 2 points, the slope of that secant line is this right here. That's the f of b minus f of a over b minus a. So mean value theorem says that on this interval between a and b, whatever the slope of the secant line is between those 2 points, that has to have the same, there has to be a point between a and b where the derivative, which means the slope of a tangent line, has to be equal to the slope of that secant line. All right, so there has to be a point where the slope of the tangent line equals the slope of the secant line somewhere between A and B. All right, so let's look at a AP question that involves mean value theorem. All right, so on this it says the functions f and g are differentiable for all real numbers, and if it is differentiable, that means it is automatically continuous, and g is strictly increasing. The table above gives values of the functions and their first derivatives at selected values of x. The function h is given by h of x equals f of g of x minus 6. So I'm going to jump down to part B right here. It says explain why there must be a value c between 1 and 3 such that h prime of c is equal to -5. All right, so if you go back to this picture right here, in order to find the secant slope, we need 2 coordinates. We need this point and we need this point. We need 2 coordinates. So related to this problem, if we're looking at between 1 and 3 and we're looking at h, what we need to figure out is what is h of 1 and what is h of 3. All right, so let's plug into our equation. It says h of x is f of g of x. Well, that means that would equal f of g of 1 and then minus 6. Well, if you look at g of 1, that is equal to 2. So this now becomes f of 2 minus 6, and f of 2 is equal to 9. Which is equal to 3. All right, so h of 1 is equal to 3. Now we need to find h of 3, which would equal f of g of 3 minus 6, and g of 3 is 4. So this becomes f of 4 minus 6, and f of 4 is -1, so this becomes -1 minus 6, which is -7. All right, so now if we look at what is h of 3 minus h of 1 over 3 minus 1, which is just our delta y over delta x, that's going to give us -7 minus h of 1, which is 3, over 3 minus 1. Well, that's negative 10 over 2, which is negative 5. So what this tells us then is the slope of the secant line between 1 and 3 is negative 5. Well, if the slope of the secant line is negative 5, that means that there has to be a derivative, or in other words, an instantaneous rate of change that is equal to negative 5 also somewhere between 1 and 3. And that's by the mean value theorem. Now, just to look at this one right here, Part A says, explain why there must be a value r between 1 and 3 such that h of r is negative 5. This is talking about there being a y value that's equal to negative 5, not a derivative that's equal to negative 5. So if you look at the 2 points, one of them has a y value of 3, the other one has a y value of negative 7. So do we have to have a y value of negative 5 somewhere on that function between 1 and 3? That answer is yes, because of the intermediate value theorem by IVT. Because negative 5 is between negative 7 and positive 3. This is how they would score that problem on the AP exam. For Part A, you get 1 point for finding out what h of 1 and h of 3 is, and you get 1 point for your conclusion. And then for Part B, you get 1 point for finding the change in h over the change in the x values, and then you get 1 point for writing out your conclusion that you are using mean value theorem. All right, so the last problem, I think, it's the last problem here. It says the graph of a differentiable function f is shown above on the closed interval from negative 4 to 3. So closed interval means we do have some endpoints here and here. How many values of x in the open interval from negative 4 to 3 satisfy the conclusion of the mean value theorem? All right, so mean value theorem says that if we can figure out what the slope of this secant line is, our function would have to have that same tangent line slope in at least one place. Now this question says how many values of x are going to meet the requirements of the mean value theorem. Let's think about tangent lines that can be drawn that are parallel, because if the lines are parallel, they're going to have the same slope. So somewhere right here, you are going to have a tangent line that is going to be parallel to this secant line. So you have a tangent parallel to the secant, means the derivative equals the slope of the secant line. All right, so that is your mean value theorem. This does occur somewhere between negative 4 and 3. Now, how many other places does this happen? Well, you're going to have another point down here somewhere where the tangent line will be parallel to the secant line, and you'll have another point somewhere over here where you would have another tangent line that is parallel to the secant line. So what that means is that there are 3 places on this interval that are going to meet the requirements of the mean value theorem.